Hi, this video is about absolute value equations and inequalities. This is the special cases edition. Please watch my previous video on absolute values if you want to just see how to solve your normal equation and inequality, because these are special cases. Alright, let's take a look at our first problem. Remember, we first need to do the opposite of order of operations, so anything added or subtracted needs to be removed. So we're going to start out by adding 2 to both sides. We get the absolute value, 10 times the absolute value of negative 2 plus x equals a negative 70. The opposite of multiplying by 10 is to divide by 10, both sides. And we now get the absolute value of negative 2 plus x equals a negative 7. Let's stop right here and take a look at this. This is saying that the absolute value of a number, which we know are going to be positive outcomes, absolute values are always positive, are equal to a negative number. Positives are never equal to negatives, so this would be an example of no solution. If you were to continue to work this problem, you would get 2 solutions. However, if you stored those values in the calculator and typed in your original problem, you would find that the answer solutions would not check. Let's go ahead and take a look at our next problem. Okay, here we have negative 4 plus 9 times the absolute value of 2a plus 9 is greater than a negative 85. I need to caution you because I find that this is a common mistake with students. They take a look at this outside piece and they have the urge to add 9 and negative 4 and come up with positive 5. This is not what it means. If we were to remove the negative 4 from our problem, you can see that 9 has not been added to, but this is a multiplication scenario. So let's go ahead and put that negative 4 back in there. So we don't add those two together. This is a negative 4 that's been added to this piece over here. So we're going to get rid of it. We're going to add 4 to both sides. This cancels out. We get a positive 9 times the absolute value of 2a plus 9 is greater than a negative 81. At this point here, we're going to isolate the absolute value by dividing by 9, both sides. And we get the absolute value of 2a plus 9 is greater than a negative 9. So what is this saying to us? Let's take a look at that before we continue to solve. This is saying positive numbers are greater than negative, whatever the negative number may be. If we put any number in place of a, whether it be a positive or a negative number, as soon as we take the absolute value after multiplying by 2 and adding 9, we're going to get a positive number. Positive numbers are always greater than negative numbers. So this answer would be all real numbers. Any number we put in place of a, multiply by 2 and add 9, and then take the absolute value of it, we're going to see any number is going to allow this to be greater than a negative number. The other symbol that is often used for representing all real numbers is this funny shaped R with an extra line in it. What if you didn't notice and you kept on solving? Let's take a look at that. If we kept solving, we would have this is a greater than sign, so this would be or 2a plus 9, flip the sign and negate. Let's go ahead and solve. We no longer need our absolute value. We set up our second scenario. So we are going to start it by subtracting 9. 2a is greater than a negative 18. Dividing by 2, and we get a is greater than a negative 9. Let's take a look at our other problem. Again, subtracting 9 from both sides, we get 2a is less than 0. Dividing by 2, a is less than 0, because 0 divided by 2 is 0. Now, if we were to put this on our number line, let's see what that looks like. If we were to graph, and I'll graph it in red, a is greater than -9, it would be an open circle, and we'd be shading all values greater than -9. A is less than 0, again, open circle, and we would shade all values less than 0. So we can see it overlaps, but also continues in both directions. Basically, all of our numbers are being covered. So the solution, all real numbers, applies. Let's take a look at our last problem. Once again, here is our inequality. We want to start by getting rid of anything that's been added or subtracted. So we're going to start out by subtracting 5. We get 6 times the absolute value of 5n plus 7. That cancels. And we get less than or equal to a -18. Now we need to get rid of our 6 that's being multiplied. The opposite is to divide, leaving us the absolute value of 5n plus 7 is less than or equal to a -3. So what does this one say? Let's take a look. Whatever we put in place of n, multiply by 5 and add 7 to it, and then take the absolute value, we're going to get a positive number. This is saying positive numbers are less than or equal to negatives. Now we know the positives are not less than negatives, so this would be an example of no solution. If you were to continue the problem and solve it, you would get a value for n, 2 values for n exactly, and when you were to plug them back into your original equation to test them, you would find out that you would get a false statement. And that's because positives are never less than or equal to a negative number. So hopefully you're going to catch it at this point here and save yourself a whole lot of work. Just pause before you set up your scenario, whether it be an and or, and then write it down, flip the sign and negate it. Stop before you do that and see what this is saying to you. It'll save you a lot of time and work. If you're having any trouble, you might want to rewind the video, but you can always come into Cab Morning. We'll be glad to help you.